So here we're going to be finding the slope from ordered pairs. So it's really the same thing that we were finding before. We're still talking about the rise over run. But now we don't really need to deal with it on a graph. We don't actually need to count all of those points. You always can. If you feel more comfortable with that, you can always graph them and count the rise over run. But that can be a little bit of a pain, and there's a much easier way to do it. The rise is really just counting how many spaces it goes up or down, which is really finding the difference between the two y values. So don't get confused by how these are written. This is saying this is the first set of coordinates, x1 and y1, so the one on the left usually when we start counting. And then we count to the one on the right, or the second set of coordinates. And this is just saying it's the second x value and the second y value. That's all that's saying. These subscripts are not exponents at all. It's just a label saying that this is the second set of coordinates, this is the first set of coordinates. So I could count my rise and run, and you really could always do that if you want, but instead of having to actually draw it each time, finding the difference between the y values and the difference between the x values is identical to finding the rise and run. If I wanted to figure out how far it is from 2 to 7, you can really just subtract those and find that it's 5. So a much simpler way of counting is just using the difference between these two coordinates. So the way I'm going to write this is y2 minus y1. So that's saying I'm going to take this y value and subtract this one from it, and I'm going to do the exact same thing with the x's in the same order, x2 minus x1. So I'm taking these coordinates and subtracting these from them. That finds the exact same thing that I was counting out before, the rise over run. So if I wanted to find the slope between these 2 points, I could graph that, or I could label these as my x1 and y1, and x2 and y2, and just use my slope formula. y2 minus y1, the second y coordinate, minus the first y coordinate, divided by the second x minus the first x. It has to happen in that order. I need to make sure if I do this minus this, I do this one minus that one. I have to have these as matching coordinates there. You are actually allowed to flip this. The order of the question could just be rearranged. If I said I wanted to find the slope between this point and this point, I could rearrange that and write it exactly backwards of what I have here. I just need to make sure that these are lined up vertically. So 8 as the y2, and then 18 is my y1, and then 9 as my x2, and 11 as my x1. This would give us 10 over 2. This would give us negative 10 over negative 2. Either way, that's going to simplify to a slope of positive 5. So we may also want to find the slope between points in a table. Just like before, it actually doesn't matter which points we choose. We can find the slope between any of these 2 points, and it represents the slope of the entire line. The slope is consistent through the entire line. So I can pick any of my 2 points as my x1 and y1. I'd rather not deal with negative numbers here, so I'm going to label this is my x1, this is my y1, and this is my x2, this is my y2. Again, you could choose any points. I'm just choosing the positive ones because those are going to be the easiest to subtract. So I'm going to do y2 minus y1, that's my rise, over x2 minus x1, that's finding the run. So that's 4 minus 1 over 2 minus 1. So that equals 3 over 1, or really just 3. So the slope between any of these 2 points is just 3. And I'm going to do a few more examples finding the slope between 2 sets of points in a table. Again, you can choose any 2. I'm going to choose these 2. 0 is always going to be the easiest to use, so if I do y2, I'm going to label this is my y2, this is my y1, this is my x1. Remember, those have to match. The x1 and y1 have to be together. And same thing with the x2 and y2. And then when we write out this equation, we have to write it in the right order. y2 minus y1 over x2 minus x1. So 6 minus 0 on top, and 3 minus 0 on the bottom. So it's 6 divided by 3, or a slope of 2. Same kind of thing. I'm just going to label each of these. I'm going to just pick randomly, I'm going to say this is my y2, even though it's going to be a little bit out of order. This is my x2. I'll call this x1 and call this y1. So now I'm writing it in this order: y2 minus y1, -3 minus -7. And then on the bottom, x2 minus x1. So you could have actually completely flip-flopped these, and the signs would change, but the overall fraction, the overall slope would remain the same. I'm going to subtract there, get -8, and subtract there and get a +4. So it's 4 over -8. I could divide each of those by 4 to simplify it, and I would get 1 over -2. In general, when we write our slopes, we're actually going to take that negative sign and put it on the top. This is identical to a negative sign out in front, and it's also identical to just bringing that up to the top. I'm going to write it as -1/2 as my slope, because this really represents what's happening in the graph. This is my rise. Oops. And this is my run. It's showing that I'm going down 1 for every 2 that I go over. So throughout that graph, it's gradually going down 1 over 2. So it just gives a clearer picture if you keep the sign with the top of the fraction there. So here again, I'm just going to be careful about how I label my points. I'm going to call this my x2 and y2. I'll use this one as my x1 and y1. It really doesn't matter which 2 points that you use, as long as you're consistent and as long as you're kind of meticulous about how you write this into that equation. y2 minus y1 on the top, 20 minus 0 on top, and then 10 minus -10 on the bottom. So we'd get 20 from that subtraction, we get 20 from that subtraction, and 20 divided by 20 is just 1. So this slope, I just want to clarify what that's really saying. When I don't have a fraction, I'm really imagining a denominator of 1. So that's saying for every 1 that I go up, I'm going over to the right 1. I go up 1 and over 1. One last example, I'm going to say y2 minus y1, -16 minus -6 over x2 minus x1. 2 minus 0 on the bottom. So -16 minus -6 is a -10. 2 minus 0 is a +2. So that simplifies to -5 as my slope. So this is going down 5 every time it goes over to the right 1 spot.